All right, so here's your first chemistry lesson: elements, compounds, and mixtures. Even though it only says element, but we know better. Now, the first thing we're going to discuss, since now the animations are working for us, is a compound. A compound is a pure substance. It's made of different elements. So when I say a pure substance, let me give you a few examples. And you may know these common names, but they have chemical names: water, salt, and sugar. Now, water is a pure substance, but if you put dirt in it, it isn't anymore. If you put salt in the water, it's not pure anymore. That means by itself. Salt is a pure substance. Sugar by itself. If you put dirt in there, no longer pure. It will be called a mixture, which we'll talk about in a moment. So you have your water, salt, and sugar. But those are the common names. There are also our chemical formulas. So water is made up of 2 H's and 1 O. Therefore, it has the formula H2O. So it has the element hydrogen and oxygen. Salt has these 2 elements, sodium and chloride. All right, so they're made from different elements put together. All right, so that's 1 sodium, 1 chloride. And sugar, or in this case, its real name is sucrose, C12H22O, or O11, yes. A lot of different types of elements. Now, to give you a big hint, this is a lot of living things. So it's not the best example, but if you think of a tree, you think of this. If you think of stuff in soil, think of this. If you think of sugar, think of this. Your chips, think of that. Rice, and so on. All right, so we see how these things are pure, all right, and they're made up of elements. So now let's talk about what an element is. An element by itself is a pure substance. What's really neat, and let me see if I can give this a little drawing. If we took a container of water, and that's water, believe it or not, and we took a little battery, strong enough battery, there's little electrodes, little terminals on the end, and you put one wire on one side of that water, and you took the other wire and put it on the other side of the water, we know that water is H2O, but then we'll start seeing bubbles on one wire and bubbles on another. It's because it'll separate the H's and the O's, but it's not found like that in nature. It cannot stay just as an H or O. Some can, some cannot. You gotta learn exceptions. So that's H2, and the other side is O2. It's called electrolysis. So these compounds can be further divided. Now, an element is the purest and cannot be divided anymore. So to give you some examples, that could be like iron, Fe. If we separate sodium from chloride, then we would just have sodium. Right? It doesn't like to stay like that. In fact, it has to be coated and put in a jar of oil in order to not break down. Calcium, hydrogen, oxygen, chlorine. Now these little 2's, that means that's the way they have to be found to keep them stable, because things need to be stable. Now a mixture. A mixture is a combination of things. It's a combination of compounds. So if you put salt and water, that's a mixture. Sugar and water, that's a mixture. Salt and sugar, that's a mixture. You know, the possibilities are endless. There are 2 kinds. All right, so there's 2 kinds of mixtures. We have these 2 kinds, and these are both of T. Can you tell the difference? All right, well, here are the 2 kinds. The first one is a homogeneous mixture. Now, the word homo means one or the same. The other one is a heterogeneous mixture, or heterogeneous. Hetero means different. So, homogeneous and homogeneous is more my biology. There should be a little E in there. Right there, between the N and the O. All right, it's the one that looks uniform. That means it looks like one thing, all right? And it's consistent. It looks the same all throughout it. Heterogeneous looks different, so it does not look like one thing. So between these two, can you decide which one is homogeneous and which one is heterogeneous? Let's see. There we go. This T you can see clearly through, but if you look at this T, you can clearly see there's something else in it, which is the ice. Now if you put sugar in there, like in this T, it's water with the T, just like as well as sugar. But you know what? If you put a rock in there, it quickly becomes a heterogeneous mixture. So now, your mission is to find one compound in this house. I originally said two, but let's take off that. To find one element and find both types of mixtures. So that's for a total of 4 things you need to bring to me. Next time I do this, we're going to learn some differences in these elements, because if you know what the elements do, then you know what the compound does, or at least something close to it. And we're going to separate elements into metals, nonmetals, and what's in the middle? Metalloids, which means metal-like. So what you need to know next time is some elements. Ca is calcium, Na is sodium, hydrogen, oxygen, carbon, chlorine, nitrogen, potassium, magnesium, and we can put in iron, since we already seen that one. Now when you see these, notice the first letter, even if it's only one, the first letter is always capitalized, and the second letter is always lowercase. All of these are. Otherwise, you're not representing elements. All right, and that is it.